Hey everyone, welcome back. So today, we're diving into something pretty mind-bending. How does an AI, remember stuff? We're going to unpack the huge breakthroughs that gave machines a real long-term memory and the ability to focus. And trust me, this changed everything.
Okay, so let's get right to the core problem. Think about it. How can a machine read something huge, like a giant novel or a decade's worth of medical records, and connect a tiny detail from the very beginning to something super important way at the end? Right? That's the challenge. How do you connect those dots when they're so far apart? That's what we're digging into.
All right, to make this super clear, let's use an analogy. Picture an AI as Dr. Strange. A patient walks in today with blurred vision. Now, that symptom alone could mean anything. But Dr. Strange needs to access his long-term memory, that patient's file from 10 years ago, to see that, there was a diabetes diagnosis back in 2015. Suddenly, everything clicks. Without that long-term context, the new symptom is just noise. And that right there was the exact problem AI was facing.
Which leads us perfectly into our first big topic, what I like to call AI's forgetfulness problem. See, the early models, they were actually pretty smart with short-term stuff. But the second you gave them a long sequence of information, phew, it was like they had a severe case of amnesia.
So if you look at this timeline, you can kind of see how AI memory evolved. The first attempts were these things called recurrent neural networks, or RNNs, and they worked, sequentially. They'd read one word, then the next, trying their best to hold on to what came before. The problem? The longer the sentence, the more the stuff from the beginning just kind of vanished. It just faded into the background. Now, there's a technical name for this. It's called the vanishing gradient problem. The easiest way to think about it is like a radio signal that gets weaker and weaker the farther you get from the tower. For the AI, this meant that by the time it got to the end of a long document, the super important info from the beginning was basically gone. It was just static. So yeah, long-term connections were pretty much impossible. The mission was clear. AI needed a whole new memory system from the ground up. And that breakthrough? Well, it arrived. And its name was the Long Short-Term Memory Network. You'll hear it called an LSTM. And this wasn't just a small step. It was a total game changer. It gave AI a completely new and way more sophisticated way to handle its memory.
Okay, so the best way to get your head around an LSTM is to imagine it's not just a memory bank, but a really, really well-run warehouse. It's not just some big empty room where you throw information. No, this place has a system. It has managers who are constantly deciding what new information to bring in, what old stuff to get rid of, and what's important enough to be put into long-term storage.
And at the heart of this warehouse, you've got two different memory lanes. First, there's the cell state. Think of this as the main conveyor belt, the long-term archive. It carries the really important context all the way through the process. Then you've got the hidden state. This is more like a small, short-term shelf right next to the worker, holding just what's needed for the very next step. The real magic, of course, is in how these two things work together. So, who are these managers running the warehouse? Well, they're basically three gates controlling the whole flow of information. First up, you have the forget gate. This is your archivist. It looks at old information, like, say, a patient's flu from 5 years ago that's now resolved, and decides, yep, we don't need this anymore, out it goes. Then you have the input gate. This is the acquisitions department. It sees new information, like our patient's blurred vision, and decides if it's important enough to be put into that long-term storage. And finally, there's the output gate. This is the information officer. It looks at the immediate task and pulls just the right piece of info from the long-term archive to help make the next decision. So LSTMs were incredible. They basically solved the long-term memory problem. But it turns out that just remembering everything isn't quite enough. The next level, the next giant leap, was teaching AI not just to remember, but to focus. And that, my friends, is where something called the attention mechanism enters the story. So here's the problem LSTMs still had. It's called the translation bottleneck. Let's say you're translating a really long, complicated legal document. An LSTM model would have to read that entire sentence in English and then try to cram, literally cram, all of that meaning into one single compressed thought before it could even start translating it into French. And you can imagine, when you squeeze everything down like that, you're going to lose stuff. Those critical links between a word at the start and a word at the end, they just get lost in the shuffle.
Attention just blew that whole process up. It was a complete game changer. The performance on longer sentences just shot through the roof. You can see it in the data. But the real magic isn't just that it's better, it's how it's better.
Instead of cramming everything into one thought, attention lets the model look back over the entire original sentence at every single step. It creates these direct little cheat sheet links so it can focus on the exact English words it needs to translate the one French word it's working on right now. It's brilliant.
Honestly, this is the best analogy for it. Think of attention like a judge in a courtroom. The judge doesn't try to memorize a 200-page legal contract from start to finish. No way. Instead, when they're about to make a ruling, they flip back to page 77 and point to the exact clause that matters for that specific point. That's what attention does. It's not about remembering everything, it's about knowing exactly where to look. That's the power of focus.
Okay, I know this all sounds kind of high level and abstract, but these ideas aren't just sitting in a textbook. They translate directly into the code, into the practical settings that engineers use to build these things. So let's take a quick peek under the hood. Don't worry, no heavy coding required.
So you don't have to be a coder to get this. When someone builds one of these models, they're setting things like its memory capacity, how much it can hold. But one of the coolest tricks they use is making it bidirectional. This is genius. It basically lets the AI read a sentence forwards from left to right, and then read it again backwards from right to left. Think about it. That gives it a way deeper understanding of context, just like when we reread a confusing sentence to really get what it means.
All right, so you might be thinking, okay, this is cool history, but why does it matter now? Well, it matters because LSTMs and attention aren't just relics of the past. They are the absolute bedrock. They're the foundational pillars that almost all of modern AI is built on. You can see the evolutionary line so clearly. First, you had the basic RNNs that couldn't remember a thing. Then, LSTMs came along and gave AI a solid, reliable long-term memory. Then, attention showed up and gave it the superpower of focus. And when you combine those two things, a great memory plus the ability to focus, what do you get? You get the direct ancestor of what we call the transformer architecture. And that's the engine running things like ChatGPT and basically every other cutting-edge AI you use today. And the impact this stuff has on the real world, it's just massive. We're talking about medicine, where it can analyze a patient's entire life history. In finance, it's hunting down complex fraud patterns that a human would miss. This is the tech behind super accurate legal translations, the real-time captions you see on videos, and even models that help us understand long-term climate trends. It's everywhere. So if you're prepping for an interview or just want the key takeaways, here's the bottom line. For LSTMs, you've got to know about the two memory states, the long-term cell state and the short-term hidden state, and how those three gates manage everything. For attention, the big idea is how it broke through the old limitations and gave models the power to focus, which directly led to the transformers we have today. Nailing these concepts is really the key to understanding how modern AI actually thinks. So there you have it. We've seen how AI went from having the memory of a goldfish to having a sophisticated, gated memory system with LSTMs, and then how it learned to focus that memory with attention. It's been an incredible journey, which really just leaves us with one big question, right? Now that AI can remember and focus, what's the next great challenge? What's the next hurdle it has to overcome to truly, deeply understand our world? That's something to chew on. Thanks so much for joining me.